Okay, my little is in bed, so let's talk about super theoretical physics. Let's talk about dark energy, dark matter, and Anthko's theory of time and Occam's razor. Occam's razor says the simplest solution is probably the right one, and that tends to be true more than often than not. And at a very basic level, dark energy is the uh, theoretical principle used to describe the reason why the universe is consistently expanding at a consistent rate despite forces such as gravity. And at a very basic level, dark matter is the unseen, unmeasurable matter within celestial bodies, such as galaxies, that give them the extra um, matter required to create the gravitational forces to hold them together uh, despite universal or the consistent expansion of the universe. So, completely contrary to dark energy, Occam's razor says the simplest solution is often the right solution. The simplest solution being that there are not two different things acting in complete opposite ways to create both of those effects. My explanation would be Anthko's theory of time, which would suggest that time particles or temporal quanta um, form a viscous solution that has some elasticity among the surface tension, um, which holds celestial bodies such as galaxies together. And outside of those galaxies, the density of the quantum, I apologize, the density of the temporal quanta is reduced such that the quanta solution is negligible, which permits that consistent expansion of the universe from the center point, which is believed to be the Big Bang and the origin of the universe. And Anthko's theory of time actually can explain some of that, the Big Bang as well. Um, so there it is. Anthko's theory of time says that celestial bodies are held together by the elasticity of the surface tension of temporal quanta, which fill in those areas of the universe, and the expansion of the universe is due to a reduction or negligible amount of temporal quanta between celestial bodies or celestial organizational units such as galaxies. On a side note, and kind of also awesome, um, Anthko's theory of time explains time travel, but it's not traveling forward and backward through history. It's for traveling through space or across vast distances outside of our frame of reference, and in doing such, traveling in a way that appears to be traveling greater than the speed of light. So, if you were to travel from Earth at the year 2000 and you traveled for, say, 100 years, uh, using Anthko's theory of time, if you were to maneuver within that time quanta effectively, after 100 years, you could look back at Earth and see in the distant past, much further than 100 years, because in the frame of reference of time in which you were traveling, you would have been traveling at a speed that um, was slower than the speed of light, but in the frame of reference from Earth, you would have been traveling at a speed of light that far exceeded, or you would have been traveling at a speed or velocity that far exceeded the speed of light, because you wouldn't be in the same time-based frame of reference. I mean, it's a lot more nuanced and detailed than that, but that's just a very basic explanation. All right, cool. I'm going to geek out some more on super theoretical astrophysics based on the way I understand them. Cool. Bye.